Welcome to this explainer. Today, we're diving into two absolutely massive, highly starred open source tools that are completely redefining modern development workflows. Look, if you build software, you already know the landscape is shifting rapidly. Our tools are supposed to make us faster, more agile, and way more productive. But lately, well, sometimes it feels like they just add unnecessary bloat and, honestly, massive unpredictable invoices at the end of the month. We're seeing this huge push towards incredibly powerful tooling, but with that comes a whole new set of challenges that pretty much every developer and engineering team has to face. So let's dive into this. Think about the heavy reality of modern development for a second. Our tools are getting smarter, our assets are getting incredibly large, but the cost of renting your infrastructure? It's absolutely skyrocketing. You know the pain, the sheer agony of watching your per-seat pricing scale up exponentially exactly when your startup finally starts getting some real traction. We're relying more and more on third-party services that charge by the user, or by the gigabyte, or by the API call. Which brings us to a really fundamental question. What if you didn't have to rent? Seriously, what if you could actually own your entire AI and data stack? Because we're kind of caught in a tug-of-war right now. On one side, you've got proprietary lock-in. This is that friction of paying massive per-seat licenses for AI assistants and struggling with rigid legacy version control systems that literally just buckle under the weight of modern application data. It's that constant anxiety of vendor lock-in where you're terrified to change providers because your entire workflow is held hostage. But then on the other side, you have open source freedom. This is about real flexibility. We're talking about self-hosted, user-owned alternatives that let you bring your own models, define your own infrastructure, and finally burn those restrictive recurring bills. It's about taking the power back and building a stack that actually works for you and not your vendors. All right, here's our roadmap for today's explainer. We'll be looking at 1. Next-gen open source tools. 2. OpenTag, your AI agent. 3. How OpenTag works. 4. Lore, version control evolved. 5. Lore's high-scale architecture. And finally, 6. Owning your dev stack. Let's get right to it. Starting off with Section 1, next-gen open source tools and the shift to self-hosting. We're about to look at two specific repositories today, one designed for AI chat agents and one designed for massive data management. And while they tackle very different problems, they both share the exact same core philosophy, giving control right back to the developer. Moving to Section 2, OpenTag, your AI agent. This is your liberation from per-seat pricing. Created by CopilotKit, this tool directly tackles the AI overhead problem we were just talking about. Their GitHub repo puts the value proposition perfectly. They say, think of it as having Claude in your workspace, except open source and self-hosted. Boom! That instantly clicks, right? You get the full power of a cutting-edge LLM answering questions, drafting code, and analyzing threads right inside your chat platform, but you actually own the runtime. Think about what that means for your peace of mind. You aren't shipping your sensitive internal discussions off to some block box you don't control. You bring your own model, you wire it up to your own internal tools, and there is zero lock-in. You decide exactly how, when, and where your data gets processed. So let's talk about what this actually lets you do. First off, because there's no per-seat pricing, you don't have to ration out licenses to just the senior engineers or the executive team. You can deploy this to your entire organization on day one. But it's not just a basic text chatbot either. It features generative UI, meaning the agent can render a breakdown, a table, or even a bar chart directly inside your conversation flow. It also supports human-in-the-loop approval gates. And let me tell you, this is a total lifesaver. It means the AI can draft a complex database migration or suggest a massive codebase refactor, but it will only execute that action after a human explicitly clicks approve. So no rogue AI accidentally dropping your production database. And since it runs on CopilotKit's OpenBot SDK, it's completely platform agnostic. It's built for Slack first, but the exact same code runs flawlessly on Discord, Telegram, and even WhatsApp. Now, you might be thinking, okay, self-hosting an AI agent sounds like an absolute ops nightmare. But let's move to Section 3, how OpenTag works, and see why self-hosting has been made brutally simple. The architecture completely demystifies this, reducing a fully working bot down to just 4 incredibly approachable steps. First, you create a Slack app using their provided manifest file. This gets you your connection tokens without having to dig through a dozen different API portals. Second, you set just 3 secrets in your environment file. Yep, that's it, just 3. Third, you run it directly from the CopilotKit monorepo root. And fourth, you just talk to it. It's a completely approachable task to bring this AI in-house. We're talking maybe 5 minutes from your initial clone to your very first conversation. And here's what it looks like in practice. You literally just type Add OpenTag, summarize this thread, and file it as a bug. The agent reads the thread context, formulates the summary, calls your connected tools like Linear or Notion, asks for your approval, and executes the task. Think about how much time you usually waste context switching manually to do all of that. Copying text from Slack, opening a new tab, logging into Linear, formatting the ticket, linking back to the thread. It is exhausting. OpenTag turns a complex, multi-tool workflow into a single, natural language command, all running on infrastructure that you fully control. Okay, so we've solved the AI pricing problem. Now, what about our data? Let's pivot our spotlight to Section 4, Lore, Version Control Evolved. Built for massive assets, this is Epic Games' answer to the massive friction of managing huge binary files. Just to instantly establish some credibility here, Lore has already snagged roughly 6.8 thousand stars on GitHub. The community is heavily rallying behind this because it solves a problem that pretty much every developer working with rich media faces. If you've ever had your entire morning completely ruined by waiting half a day for a standard Git repo to clone, just because a designer uploaded a few 4K textures or a giant 3D model, you know this pain perfectly. Traditional source control simply was not built for modern, massive binary assets. Let's compare the legacy constraints against Lore's modern approach. Standard tools like Git are amazing for source code, for sure, but they notoriously fail when faced with gigabytes of binary game assets. The old way requires heavy upfront downloads of the entire repository history. The Lore way uses sparse, on-demand hydration. Think of this like streaming a movie on Netflix instead of waiting to download the entire 4K video file before you can finally press play. Your workspace stays lightweight and only fetches data exactly when you need it. The old way means painfully slow branch switching when massive files change. The Lore way offers lightweight, incredibly fast branching. And where the old way duplicates large binaries over and over, Lore uses chunked, deduplicated storage. It's actually so powerful that it's the built-in version control system for the Unreal Editor for Fortnite. So, how did Epic Games actually achieve this unprecedented scalability? Let's look at Section 5, Lore's high-scale architecture, where speed meets cryptography. The foundational technology powering Lore is the Merkle tree. Think of this as a digital fingerprint for your entire project. It's a cryptographic data structure where the repository state is stored by a content hash. This means the revision's hash signature is mathematically derived from its actual state, including parent hashes and data hashes. It forms this immutable chain. If even a single byte changes in a massive multi-gigabyte project, the hash changes. This gives you a fully verifiable, tamper-evident source of truth, while simultaneously enabling insanely fast comparisons and data reuse across your entire history, without having to blindly scan every single file. Let's break down these mechanics. Sparse hydration is the absolute game changer here. It completely eliminates the dreaded wait times of traditional checkouts because you aren't downloading everything up front. Chunked storage means large files are broken down into smaller pieces, so if you change one tiny texture in a massive binary asset, Lore only updates and transfers that specific chunk rather than duplicating the entire huge file. Centralized caching scales the throughput for massive teams. This is the real-world magic that allows an entire studio of 100 artists to work on the exact same massive game environment without their computers grinding to a complete halt. And finally, verifiable history ensures strict cryptographic integrity across every single commit. And here's a really surprising and interesting fact about the repository itself. Looking at the codebase breakdown, you can see how heavily Epic Games leaned into Rust. At nearly 82% Rust, it's incredibly clear they prioritized memory safety, strict concurrency, and raw performance. Look, when you're building a tool designed to ingest, process, and transfer gigabytes of binary game data every single second without crashing, choosing a robust language like Rust is absolutely critical to handling that massive scale. Bringing both of these incredible tools together, we arrive at Section 6, Owning Your Dev Stack. The future is truly open. The crucial takeaway you should leave with today is that the tools we rely on are rapidly maturing. Whether it's an AI assistant like OpenTag smartly reading your Slack threads, rendering complex charts, and triggering workflows without trapping you in some vendor lock-in, or a repository like Lore efficiently holding massive game environments with cryptographic integrity and absolutely zero bloat, the common thread is beautifully clear. Development is getting faster, it's getting significantly more scalable, and most importantly, these tools allow your entire pipeline to be fully owned by you. You no longer have to settle for prohibitive per-seat licensing, and you absolutely no longer have to force massive binary assets into tools that simply weren't built for them. The open source community is actively handing the keys right back to developers. So I'll leave you with this question to think about. Which part of your stack will you take back next? Thanks for joining me on this explainer, and keep exploring.